All right, let's look at the homework 15.4, problem number 3. All right, so we're going to use a double integral to find the area of the region, which is a one loop of the rows. R is equal to 9 cosine of 3 theta. All right, so let's do that. All right, so first we need to draw a picture. All right, so here is the x-axis. And here is the y-axis. All right, so I'm going to start with theta equals 0. So I'm going to put theta is equal to 0. So that's the positive x direction. And if theta is 0, cosine of 0 is 1. So it's going to take the value of 9. All right, so I'm going to put 9 here. All right. All right, then, so I'm going to just put a dot there. So here's a dot there. All right. Then let's say next time a cosine becomes 0 would be cosine of pi over 2. So to make, so we said 3 theta equals pi over 2. So theta is going to be pi over 6. So that's 30 degrees. So if you look at the 30 degrees, so here, pi over 6, right? So this is going to be theta is equal to pi over 6. Then the value is going to be 0. So it's going to hit here. So it's going to look kind of like this, right? Then next angle would be, let's see, we want to get next angle, which would be maybe pi over 3, so which is going to be right here, right? So maybe we should look at the value every 30 degrees or pi over 6. So this angle is theta is equal to pi over 3, right? Then you have a cosine of pi, which is -1. So you're going to get -9. So along here, you're going to get -9. So you go actually on the negative direction. So it's going to go this way and hit 9 here. All right. So 9 would be the distance from here to there is going to be 9. All right, then after that, if the theta is pi over 2, all right, so you have a cosine of 3 pi over 2, right? That'll be 0. So it's going to actually comes back to there, right? Then you go another one. So this is let's see right here. All right, so pi over 2 would be, let's see, 3 pi over 6. So you have another one. So this is going to be theta is equal to 5 pi over 6. All right, so let's see, is that right? Oh, actually, I messed that up. Hold on. All right, so this is going to be 3 pi, so it's going to be 4 pi over 6. So this is 4 pi over 6. All right, if you put 4 pi over 6 here, then 4 pi over 6 is 2 pi over 3. So multiply by 3, so it's a 2 pi. So cosine of 2 pi would be 1. So you can see that this is going to actually go 1 times 9. So again, distance from here to there is going to be 9. All right, then it's almost there. So we have another one here, this angle. Let's say theta is equal to 5 pi over 6. All right, so that would be 5 pi over 2. So cosine is going to be 0. So it's going to actually go back here. All right. Then if you do theta is equal to 6 pi over 6, which is going to be pi. So cosine of 3 pi is going to be negative 1. So it's going to be negative 1 times 9, so negative 9. So it's going to go like that, right? And that completes the rows. And if you go more, then it just keeps on going over the same place. All right, so we want to know the area of the one loop. So I'll just take that one right here. All right, so we can use a symmetry. So let's try to actually find only a half of this. So let's try to find this by this guy right here. All right, then multiply by 2. All right, so the area A is going to be, all right, so we're going to set up a double integral, right? So we have area elements, so we have r dr d theta, right? Then the r is going to be from 0 to whatever 9 cosine of 3 theta is. So we have a 0 to 9 cosine of 3 theta. All right, then angle would be, so in order to cover that, it actually starts from pi, theta equals 0 to pi over 6. So it's going to be 0 to pi over 6. All right, since this only covers 1/2 of it, so I'm going to multiply by 2 because I want to get the other half too. All right, then we just have to evaluate this. All right, so this is going to be equal to 2. Right, and we leave this outside integral alone for now. So we have a d theta. Right, antiderivative of that is r squared over 2. Then we are going from 0 to 9 cosine of 3 theta. All right, then since we have a 2 on top and 2 on the bottom, we can cancel those. All right, then we can plug in those. So you have here, all right, 9 squared, so 81. So since it's just a number, I'll just place it outside. Then we have an integral from 0 to pi over 6. And then you have a cosine squared of 3 theta, right? And with respect to theta, right? Before we do that, we have to use the trig identity. So this is going to be equivalent to 1/2 1 plus cosine of double angle. So it's going to be 6 theta, right? All right, so we have, let's see, all right, so 1/2 is just a number, so I'm going to put it outside. So it's 81 over 2. And the antiderivative of 1 with respect to theta is theta. Antiderivative of cosine of 6 theta would be positive sine of 6 theta over 6. And then we're going from 0 to pi over 6. All right, so we have 81 over 2 and plug in pi over 6. And if you plug in pi over 6, so it's going to be 6 pi over 6 is going to be pi. Sine of pi is 0, so that's 0. Then if you plug in 0 there, it's 0, sine of 0 is 0. So you only get just this, all right? So we can simplify a little bit here. All right, so 81 is a multiple of 3, so we can just divide by 3. And we have 27. And divide by 3, that's 2. So we get 27 pi over 4. All right, so let's double check. Let's type it in. All right, so we have 27 pi over 4. All right, let's check the answer. Submit for testing. All right, it came back, and it looks like we got this one correctly. All right, that's it. I hope that this was clear.